So hopefully you understood isotopes in the last section, and that if the mass is different, you can have a different number of neutrons. Now we're going to learn about the electrons and how they can vary. So again, the nucleus of an uncharged atom, okay, is unchanged by ordinary chemical processes. However, atoms can readily gain or lose electrons to make something called ions. So an ion is an atom or atoms that have become charged because they have gained or lost electrons. Because they have gained or lost electrons. You got two versions here. You've got a cation, that is a positively charged atom, so it has lost electrons. And then you've got an anion, which is a negatively charged atom, so it has gained electrons. Now think about that. Think about people in your life that are positive, okay, or becoming more positive. To become more positive, you have to get rid of the negative. That's why they have lost electrons. Remember, electrons are negative, so you get rid of the negative in your life to become more positive. That's what has happened in a cation. You need to pause this, go through that a couple of times until you get that. Some people remember this because they like cats, okay, and cats are a good thing for them, and they think, ooh, I like cats. Cats are positive. Okay, a cation is positive, but it has lost electrons. Then an anion is negative, and if you think about negative people, okay, they bring on more negative, so to become negative you have to add more negative. Okay, and then again, electrons are negative, so they have added or gained electrons to become negative. And I have some counting going on here for you. I've got the sodium atom. It has 11 protons and electrons just as it is on the periodic table, but it easily loses one of those electrons, resulting in a cation with 11 protons that cannot change, and now 10 electrons. So therefore the charge is 1 plus 1. You have one more positive here. If you think of it like a balance, then you do negative. So you've got 11 positive and 10 negative. That's how you figure out the charge. 11 minus 10 equals 1. And then the sign, since it's got more protons, is going to be positive. Positive 1. Okay? And then down here we've got chlorine. It forms very readily a negative 1 anion. It has 17 protons and electrons to start. It easily gains 1. Remember, you gain negativity, you become more negative. So it's got 17 protons, 18 electrons. 18 minus 17 equals 1. And electrons are negative, so that's why it's going to be a negative 1. You'll see that as 1 minus, 2 minus, 3 minus, and so on. Every now and again you'll see it before it as well, so don't freak out if you see the negative sign on either side there. In general, you have metal atoms that are on the left and middle of the periodic table. They tend to lose electrons and become positively charged cations. And then nonmetal atoms that are on the right side of the periodic table, they tend to gain electrons. We'll talk about why they tend to gain and lose later on, and become negative anions. Please understand also that ions can be formed from one, that's pretty easy, or more elements. It's the more elements part that will end up getting you guys I will make you just memorize. There's just no way around it. You just have to memorize some of those polyatomic, the most common polyatomic ions. And so here are the two terms. Monatomic ions are ions formed from one atom. They're not going to give you a lot of grief. They're very straightforward. Again, mono is the root there. We have sodium, the positive one, oxygen, negative 2. And these should be superscripts. I don't know why I didn't catch that on my printout there. And then polyatomic, poly means many. So they're ions formed from 2 or more. 2 or more atoms. And here's some examples. You have NH1 plus, that's formed from a nitrogen and a hydrogen. And NO3 minus, that's formed from a nitrogen and an oxygen. There are a lot of these polyatomics, and again, we will memorize probably about 15 of the most common ones. In our note down here, I want you to just think about our flame tests that we did, or are going to do if we haven't done them yet. Electrons at varying energy levels, depending on how close they are to the nucleus. That's what determines their energy level. How close are they to the nucleus? As electrons become excited by heating or the introduction of electricity, and we even talked about mechanical force, or are going to talk about mechanical force, energy is released in the form of visible light. So each element has a specific, please don't say Pacific, I hate it when people say that, has a specific visible light spectrum, specific visible light spectrum that can be used by different types of chromatography equipment to identify the unknown elements and compounds. The unknown elements and compounds. One of the most common is a GC mass spec. Again, we did the flame test, or we'll be doing the flame test in here, where we just put the elements in a flame and see the visible spectrum for ourselves. This is very useful for applications such as forensics, medicine, and environmental science. And another concept that we used to study electrons was the functioning of batteries. So also remember that the movement of electrons is important in functioning of batteries, as electrons flow through an electrolyte from the anode, which is the negatively charged. Again, it should look like a word that you learned earlier. Anion is at the anode. It flows from the negative anion or anode, the charged end, to the cathode, which is the positively charged end, which again should remind you of the word cation that you just learned. And also a word that I forgot to put, I think I even left it off your test this time. We will talk about it more in the periodic table and in bonding. But your electrolyte, it has to be conductive. Okay, something that is conductive allows electrons to flow. It even facilitates the flow of electrons. And you usually think of conductive things being metal. Think about the rod and the lightning, or the umbrella, whatever. Metal we usually think about being conductive. But in chemistry, it goes beyond just metals that we're used to seeing into ions. Okay, metal ions. And so even like sodium chloride solution, once those dissociate, they come out and make a positive 1 and a negative 1. and they're floating around in the water, and because they have that charge in there, it allows electrons to flow. So conductivity, make sure you've got that word in your vocabulary as well.